Okay, folks, well, here's what we're doing. We're reviewing how to do these problems and show the right amount of work in order to get full credit, right? So we have to be able to show a little bit of factoring, and the factoring that they're going to want to see, looks like this. Let me see if I can get my pen to work better here. So you notice they're not like putting any kind of diamond box down. They notice that there's a common monomial factor of x squared in there. They factor that out. They factor this guy by kind of like a guess and check method. What factors of -6 are gonna work for me to give me a +1 for the middle term. Then we know what the zeros are if we see the factors. Now look, see how they list them really organized? I would like you to do that. This is super easy for me to grade. I can tell that you know that the 0 has a multiplicity of 2. How do we know that? Well, that's the degree, or the power, I should say, the exponent on that factor. That's our multiplicity, right? The degree is 4. I shouldn't use that word for talking about multiplicity. And then you could also, like on the next problem, it wants you to put it into Desmos, right? And a lot of people were kind of thrown off by this appropriate x and y window. Look, it's more of a graphing calculator thing. It takes a little bit of finagling to get the x and y window to look right. All you guys have to do is just kind of scrunch the screen, right? Or expand the screen until you can see a decent looking picture of this thing. I think what they're also saying is don't put a little sketch down that looks like this, okay? Don't put a little sketch down that looks like this, because that's what your window looks like. Stretch it out until it looks reasonable and pretty, all right? Once you have this organized, this information, and you're on your second problem, it would be good if you, like put dots, in my opinion, on where these things are. And you could even put them in your graph over here. Like this is 1.397 comma -5.174. Right in the directions it says round to 3 decimal places, unless the problem specifies something else. And over here put 0, 0. That's our, oh, and I like how they're labeling these things. It does say, the word local over here. And all of these, well, these two are locals, and this one would be an absolute minimum or a global minimum, depending on which calculus series you go into, what they call this thing. But notice they're not putting that over here. I don't know. I don't know if it's necessary, but it might be best to put local here, local there, and over here absolute, or global, something like that. How do we know it's the absolute minimum? Because we have a 4th degree polynomial. The polynomial is going up on both sides, right? And then it comes down here. This is the lowest spot overall. These two spots, there's higher y values. That's why this one's a local. This one here, there's lower y values. That's why this one's local. Anyways, that's probably more time than I need to spend on part B. Part C, it says using interval notation, where's the function increasing? This is still kind of messing with people's minds. Increasing means the slopes are positive. So as we go along here, like if I drew a little tangent line right here, see how that's a positive slope? This is increasing. If we had a negative slope, like let's say I drew a tangent line right over here, see how that's a negative slope? That means that it's decreasing over here. Okay, so we want the increasing interval. That's from -2 point something or other over here to 0, right? And they're only reporting, these are x values that are getting reported. We don't need the y values. And then from here, it's 1.397 out to infinity, where the function is increasing. Okay, so they just wanted to have you report only the increasing values. I hope I'm making number 1 clear. I'm going to have a video for number 2 as well. All right, thanks for watching, everybody.